But guys, if you go on the app at the very bottom, and on the YouTube app, if you're watching me on the YouTube app, at the very bottom there's like a little menu. You can slide it up and you can tweet, and I'm watching it over here. So if some chat comes up, I watch it and then I can answer here. But no one's done that yet. But we had one person watch live, which was really cool. Huh?
I said I will force myself to get up.
I should have done that too. I should have done that too. It didn't cross my mind. I thought of it like later in the day after like school done. I'm like,
I know when I wake up.
I'm gonna have to send that Twitter out.
I told my mom. I follow you on Twitter. If all my teachers did this, I could just not go to school.
that's your fault.
I know we can all be homeschooled.
I'm schooling.
Maybe we should do it, right, Mr. Anderson?
Yes, that would be amazing.
All right, let's get started because we're gonna. It's always fun to hear you guys' opinions. I want to know what you guys did. I'm gonna pick somebody. I updated the dojo, so we got everybody in now. Let's see here. Who's gonna answer this question? Elijah, what'd you come up with?
Well, I kind of overthought it a lot, and then I screwed it up. I thought about doing them as a fraction,
As a how?
like 70 over 100 and 35 over 1.
So you did a ratio?
Yeah.
So 70 over 100. Explain this ratio to me.
70% is 70 out of 100.
Out of 100, and then you did
35 over 1.
35 over 1.
Yeah.
Why 1?
Because 1 goes into 35 times.
Huh. This could have kind of worked if your ratios would have been consistent. So here you have your percentages, right? This is what that ratio would represent. This ratio would represent the cost. Okay. This is 70%, or actually technically 0.7, right? Or 70%, however you want to do it. Now, if this is what you're paying, isn't it?
Yeah.
Do we know what we're paying over here? We don't know, huh? So that would be the X. This is the total percentage, so this would be the total cost. Say that one more time? No. I wouldn't have done it as a ratio. A ratio is way harder. But you know what? It's math. Can you be wrong with the math that way? No. So if it works, right? So let's take a look. So 7 times 35, sir? So 70 times 35 is equal to 100x. Divide both sides by 100. And that would have been, I think that would have worked. Okay, now I want you guys to notice this over here. What do you need?
Look, the calculator's right there.
Oh, thank you. Thank you very much. So yeah, if you take a look at this is what's going to happen is if you want to find a part of something or percent of something, you guys remember that formula? What percent of total equals part? Let's do that real quick here. What does of mean in math? Times. So, you guys have not seen that formula? Oh, wow. My mind's blown. Okay. So, what percentage, what decimal, so what percentage of the total is blank, is part? And that's kind of the way it comes out. So, it's okay, let's make this simple then. If I want to know what 70% of something is, multiply that something by 0.7. If I want to know what 35% of 50 is, take 0.35, multiply by 50. It's that simple.
Yeah, I did that too.
Okay? And that's exactly what your ratio was. So if you take a look at 7 over 10, that's 0.7, isn't it? And then you're going to multiply 0.7 by 35, and that's going to give you the total. So if you take a look at his ratio, which was totally not wrong, it would have been 7/10 is equal to x over 35. So we cross multiply to solve this. 7, that's not a 7 at all. JK. 7 times 35 is equal to the 10x, and we divide both sides by 10. What is this right there? 7/10, aka as a decimal 0.7. So what you're really doing is taking 0.7 and you multiply it by 35. So Elijah, nice math. Nice math. Okay, you guys need to make sure you understand this part before I move on. So I want you to find right now what 13% of 62 is. Anybody have your calculator with them? Good. So please find out what 13% of 62 is. Check with your neighbors, see if you got the same thing they did. It's not easy.
18.
I got 8.06.
8.06.
I got confused because it's 13% of.
It's 13% of 62. What'd you get, Gabby?
I don't know. I got the same thing as her.
You're messing with us.
I almost got Gabby. You got
Did
it.
you really?
She goes, oh. Gabby, it's okay. You did good. Okay, you. I'm not gonna mess with you no more, Gabby. Gabby's having some trust issues with me right now. Yeah, you're just gonna multiply it to. Now, why is this 0.13 and not reading 13%? It is the same thing. Can you put 13% in your calculator and multiply that? Not 13% itself. So you have to convert it to a decimal. And how do you do that?
You move that.
Beautiful. Okay, so anyone feel comfortable with this? When was this math? This was what?
8th grade.
8th grade, 6th, 7th grade? All right, cool.
Like 6th or 5th grade?
Okay, but it's coming back to you now, right?
7th grade.
Thank you. Thank you. Thank you. I can already see where that was going. Oh, 7th grade. I remember when I did 7th grade. Okay, cool. Here's what we're doing today. Put this in your notes, please, at the very top. So, error occurs.
What we did for Bella is that, like, related to everything we're gonna do today?
No, why would I plan a bell work that's going to be related to what we're doing today? I would never do such a thing.
Be surprised not to take
I'm gonna, yes, it is, and I'm gonna show you how, okay? And I'm gonna show you how, because I'm gonna try to teach this to you. Because the way I was taught to do this was so, and you know I don't want that for you. I want it to be easy and I want it to make sense, okay? So what we're gonna do today is we're gonna find the area of sectors and the lengths of arcs. So, Daniel, what are we doing today? What's a sector? A what? Nice. I thought you were going to say he's related to Hector.
What?
That makes sense.
Okay. Did you see it from my little pictures here? Or you just knew? Okay. All right.
Oh,
Cool.
I didn't even think, just took a good guess.
That is a fantastic guess. Okay. A sector, my friends. Ooh.
Oh,
Ooh, pretty.
Khan Academy stuff there.
I love Khan Academy. But you missed a spot.
I like his voice. He has a good
He's inspirational.
speaking voice.
Except for his list. That.
Except for his math. No, I'm just kidding. Anyways, so a sector is simply a piece of a circle. And when you think sector, you need to think like a slice of a pizza, because that's what it really is. Okay? A slice of a pizza is not a little piece that goes like from here to there. Okay? It goes all the way from the center, and it's got 2 radius. So it really is just like a slice of pizza. Okay? So what you're looking at here in this purple is the sector. Oh, I should just undo that. Okay? And of course that sector can be small, it can be large, it can be, a little sliver.
So sector like section.
Yeah, fantastic. Sector like section. I use that English. I need people like you. Because I only think in one language, or actually 2 languages. Binary? So, why would we ever need to find the sector, the area of a sector? No, I mean in line.
So you don't need too much time.
You wouldn't need it, and so you don't eat too much pie?
Yeah.
Eat too much pie. I'm going to give you guys an example where actually, like, my father-in-law was blown away when sometimes I bust out with my math in real life. So anyways, we were setting up a sprinkler system. And we were trying to make sure that we got the whole yard covered with sprinklers. And you guys have seen sprinklers and how they make sprinklers?
Yeah, we made one in ag.
Did you guys?
Last year.
Like lawn sprinklers?
Yeah.
That's really cool. So anyways, there's a full 360 one, isn't there? There's a 180 one, and there's a 90-degree one, and I don't know if there's any other ones in there, but if you can find the area of a sector, make sure you have the appropriate number of sprinklers, because every sprinkler covers a certain area, distance, yeah. So if you're trying to get your yard and you have to find out all these different sectors, then you don't buy too many or you don't buy too few. Because that's the worst thing. I hate, I'd rather buy more, that's the type of person I am. But when you go to a store and you don't have enough, you're like, now I gotta take the trip all the way back to the Home Depot. But anyways, let's keep this simple. Here we have a whole circle. I don't want to find the area of a whole circle. I just want a portion of the circle. So, let's start off with something simple. Let's put some values in here. Let's call this a radius of 5. Let's go centimeters. Is that cool? And let's put in here, looks like a 60, huh? We'll keep it simple for now. We'll go 60 degrees. So this sector, I know it has a 60-degree angle and a radius of 5. I know that the whole circle would simply be pi, what? Pi squared? Pi radius squared. Pi radius squared. So my radius would be 5. 5 squared is 25 pi. There's the whole circle.
Wait, what's the bottom number?
6.
Oh, you can't see that well?
You can put it on the outside of the circle.
I could. Huh? Huh?
Oh, that's
A plus.
That's my little arrow.
I was like, what is it?
It's a little arrow.
It's an A plus arrow. No, look at it.
Make it hard.
I wanted it to pop on the purple.
Don't let your dreams just be
Does the black pop on there?
Yeah.
Or white?
Way better than that.
Mr. Williams, you do what you want. You're a real person.
Yeah, thank you.
That's what I put.
So 25 pi is the area of the whole circle, right?
Yeah.
Not the area of the
No.
sector?
No.
Okay. So, I just want that small piece. I don't want the whole circle. Any ideas?
Wait, hold on.
I could use a degree somehow, couldn't I?
Yeah.
I could use a degree somehow. How do you think I could use a degree?
Well, because the 60 angle is actually part of the entire 360, so we can like.
Huh. Somehow proportions? Okay, you're going Elijah on me. Cool. Wall?
Well, I'm pretty sure this is too much work, but see if 60 degrees and to find that, I know this is way too much work, but I was thinking divide 25 by 360 and then multiply that by 60. And that would be
So divided by
60.
360 and multiply by 60. What if we just multiplied by the fraction 60 over 360? You see how it works just like the first problem we did for the bell work? I want this much of the whole circle. Okay? So if you took 60 divided by 360, that's going to give you a percentage. And what percentage is that? 60 divided by 360. So it's about 66%. 0.66%. It's
7 at the end.
yeah, because it's rounding it up, but it's still 0.66666.
Yeah.
So
0.16.
so it's 66% of 25 pi. So if you take 0.66 times 25 pi, guess what you have?
It's what? 6 times 1.
If you take
16.5.
It's 0.166666.
oh 0.1666.
Yeah, I said one.
I'm sorry, I kept hearing 0.66. I like 0.66.
I know.
0.666.
It's just point.
We all need
So that's 0.16
Yeah, it's
It's 0.16.
of 25 pi. How much is that? She was doing the whole. Then you probably don't like 2/3, do you?
12.6.
How much?
12.6.
Did somebody confirm that for me, please? 12.6?
No, 12.56 multiplied by pi.
I did mine. What? 4 pi.
Yeah, so we're
I got
just
12.5.
It's
12.56 million.
12.56
Yeah, I got
if you
4
multiply by pi, but 4 if you keep pi in terms
Yeah.
of
We just. Yeah,
I got 4.
Oh, so you, okay, I see what you're saying. So you're saying that you just went 4 pi, and some people went 12.6.
Yeah.
What's wrong with, which one would you go for?
4 pi.
4 pi.
Why?
I was going to tell you.
12.6.
Whoa, 4 pi, you can do more math there, can't you?
Yeah. So I just do this. I know, but I
But
like
if you
this
want
one.
to find the, if you want to find the total area of the section, you got to go with the exact number.
Shelly, which one?
What?
Stay focused. Thank you. Which would you go with, 4 pi or 12.6?
12.6.
Well, why 12.6?
I don't know, it's just more accurate. No, it's not. Whoa. No, I was going to
Because you can do more with that number.
Do you want to try that again?
4 pi.
Why 4 pi?
You told me I was wrong.
Because it's more accurate. As a matter of fact, people, 4 pi is exact. Is- Did I spell that right? Why does that doesn't even look like a word?
It doesn't.
It doesn't even look like a word. What? Okay, so 4 pi is exact. The other, the 12.6, Holly? Thank you. Thank you. The 12.6, Holly, is now an approximation because it's actually just It probably doesn't end, does it? That decimal 12.61?
Yeah, it does. It's just 12.
Either just
12.56.
Yeah,
That's all it
four
is.
is not exact.
The 4 pi is exact. Oh, you guys rounded 4?
No, because I was just saying it's
we're
one.
talking about
We're just saying
0.16.
0.16.
Right. Yeah. Point one. Yeah. So this has already been. Oh, I see what you're saying.
Yeah.
So it's not
So if we did, so then what would be accurate then? What would be accurate? If I took this fraction and I simplified it first before I did anything, which is what, 1/6? 1/6, and I took 1/6, multiply that by 25 pi, then I would have 25 pi sixths. And that would be the most exact area of that sector.
It doesn't look finished though.
Because of pi?
Yeah, that's why
Yeah,
it's
and it's
12.56.
What's
It
wrong
makes
with
me feel
pi?
better.
It's just
It's all- it's not going
just
to never
an
end.
equation that's the most exact number.
If you have, yeah, if you're talking about exact solutions, pi is going to be the exact because we can't really write it down. Now, computers or whoever's doing it would know that that's what pi is. It's that big long number. And there's some numbers that we actually just use. For example, e. E is a number. There's any calculators. You guys see letter E there?
Yeah.
Well, not the green letter E, but there's a variable E. It's like 2.7. 2.71, I believe, approximately. And this one goes on forever as well. You use that a lot with logarithms and with exponential growth and stuff. Okay? Same thing with I. Okay? Square root of -1. There's some numbers that we just don't want to work with.
All we need is a P.
Okay?
Make pi.
All right, let's move on.
Oh my god, Mr. Munoz.
Yeah.
On the video, it like in class when you're in class, you don't seem like you don't realize that we stop a lot, but on the video, we
Yeah.
stop like a whole bunch of
Yeah.
times.
Yeah, well,
That's
I'm
just
like,
like
I waited
breaks.
for like
It's
10
just like-
minutes
you
waiting
just,
for us
like,
to start getting
going.
going.
But in class, it's just like, oh, okay.
And then when you
Like,
start-
you can hear everyone talking, but on the video, you can
Yeah,
only
you can hear. I can hear people like talking.
Because you're gone.
It's some-
Okay, so then you just made a point. You'd rather have class in here with me than to watch me on a video.
True.
Yeah.
It's more interactive.
Definitely, because like,
And
I
when
can
you start
hear
yelling, it scares me
like
because
what
I'm
the
like,
questions are.
What?
When you yell, it scares me. Like you start
Here?
like headphones in. Yeah.
Yeah.
it scares me.
Like, I couldn't hear any of the questions.
Like you're just watching it and it's all quiet and then you hear, hey guys! And
You're like,
it's like,
ah!
You're like,
Oh, yeah, like at the beginning, I had my earbuds in and I had it like really loud, and then you yelled.
Like that.
I like ripped my earbuds out of my computer because I
Hey,
heard.
I'm making sure you don't fall asleep on the video. It's done on purpose.
no,
And then the mic's right here, so.
good planning.
Oh, that is. It's always loud.
Scream on it. Scream on it right now.
Scream it. Scream it right now.
Everyone just
And this is gonna go back and put his earbuds in. All right, here, you do this one. Try to find me the area of that sector. And I'm talking about this sector right here.
yeah.
This one right here.
We're all talking about the video. Just about the video.
Yeah.
Maybe next evaluation I just send you to YouTube. JK. Give me the exact one, please. Do the exact one here, just so we can get the exact zack. 3 centimeters.
Oh, centimeters.
That one, I had it on my nightstand. You could.
You think it was chewing gum? Chewing gum.
112.
Is how do you get 80? Oh, it's 30.
Yeah, I'm 7.
Is there a what? All there's anyway, but I'm sure
I don't know how that happened.
I got an answer.
How do I know?
TT,
Are we keeping the flyer getting rid of?
keep it exact. So what'd you come up with?
Oh, well, then I did it wrong.
What would you have done?
You're keeping the flyer. We'll do 30 over 360 times 9 pi.
30 over 360 times 9 pi. Why 9 pi? The radius is only 3. Because you square it. Lexa, you're right. Sure, you're right. So what is this? 112? Is it 112?
Yeah, 112.
Yes,
So 9 pi over 12 becomes 3 pi fourths?
3 pi. Yeah.
Or 3/4 pi, however you want to call it.
Oh, okay.
Huh?
Okay.
How many times does 3 go into, 3 go into 36?
Oh, I thought we were trying to.
No, exact. Exact.
Okay, well, okay, if that's exact, what would you call the other one? What the next one? Estimate, okay.
Approximately.
A big number.
There's like 3 different versions, 3 different kinds of answers. There's like exact.
That was weird. Okay.
Did you get 12?
Where did we get 12?
3 times 12 is 36.
Yeah. If you simplify this ratio, well, the zeros just kind of make 1, don't they? And then what 3 goes into 36? 12 times, so it's 112 times 9 pi. Here, let me not skip any steps. This becomes 112 times 9 pi. 1 times 9 pi is 9 pi. Of course, that's just a 1. That becomes 3/4 pi. Or 3 pi fourths, however you want to write it. Exactly the same but different. Questions here? Shelly? She looks away again. Huh?
That's pretty good circle.
Thank you. I try.
Yeah, that's right.
Okay, find this one.
The exact? No, that's
Exactly, exact.
itchy. Right angle.
Oh, that's right.
Yeah, because you're not killing my 90. 45, because left corner's gonna get a bigger number. Just keep it 25. Think about it. Fraction that 25 is 1. Multiply straight up. 25 will be 4.
Hey, Paige. Of course, she said, of course it's me. I love that. I love how everybody says, like, I knew that was going to be me. All right, so go ahead. What'd you get?
I get 6.255.
6.2 pi?
How'd you get that one?
I think I know she did. She worked it out.
You did
She worked it
Oh,
out.
25 divided by 4, that's what you got the 6.25. I just put 25 pi over 4.
Okay, so if you kept it with the fractions in, it's really going to be, it's 25 pi, right? For the whole area. And obviously that's just 90 degrees of the whole thing. And if you want to simplify it, but I think everybody knows that's just a quarter of it. So divided by 4. And of course that would be the same thing. Because 4 goes in there, like, what, it's 6 times, you get 24. And then what's a quarter of 1? 0.25. So good job-o.
So we can do that too.
Guys, this one's also exact. This one is also exact.
Wait, how'd you get that one?
I'm not gonna write it down because it's gonna confuse me because I don't.
25 divided by the 4.
So I'm gonna like.
25 divided by the 4. Why is this one exact and the other one wasn't?
Because it has pi on it.
Yeah, you multiply that by pi.
This is a terminal decimal. It's 0.25 and you're done. While the other one, when we put pi in, pi is irrational. It goes on forever, so we rounded that bad boy. Okay, here, terminal, still exact. Once you put pi in there, it's 3.14. Now it's just an approximation. That's good?
Yep.
All right, cool. So that's arcs. Are there any questions on finding the area of an arc?
No.
Did you say arch?
Arc, no. Someone said arch yesterday, and they said, isn't that, because I spelled it R-A. Wait a minute. Sector. How did I say arc?
Yeah,
I'm already thinking what I'm going to do next. I apologize. So area of sector, everyone's good? Okay. What? Can I explain what? Well, I'm going to, because now we're going to find the length of an arc. And then someone said, hey, you're missing the H. I'm like, what? Yeah, it should turn to be an H at the end? I'm like, no. An arc is not an arc. She said, yeah, but the H is silent. I'm like, no. It's an arc.
Duh, H's are always silent.
Because horses love A? Is that what we're saying? Horses just love their A. And this is length? Yeah. What? Unter. It's unter. Unter. Actually, I'm going to go back to here. No, I'm going to keep the other one. But I didn't like that circle. Okay. 45 degrees. 45 degrees. This is 6 centimeters. And I'm looking for the length. I'm looking for the length of that. Whoa. Did I use my magic marker? Yeah, you did. No, I didn't.
What's magic pen?
Magic pen is really cool. I haven't used magic pen in here.
I don't think so.
I'm not liking you right now. Magic pen is really cool.
Yeah, but it turned straight.
Actually, I should use it more because I am doing circles. Check this out. If I did a circle with my magic pen, it'll close. It'll focus on something. So if I just want you to see this 45,
Oh, that's
yeah.
Look at this.
I guess James would have.
Now, if you tell me you can't see something, then I'd be like, it's right there, man. Can't you see it?
Oh, you used it before.
And then there's this one's really cool too. The shape recognition. Pop. Because I'm from the old school, man. We used to use those guys right there. A what?
really messed up.
No, if I do a mess up, it'll go oval. So if I go circle like this, it'll go oval.
No, you like
Make a triangle.
Like a
No.
No, make it all like messed up and like squiggle and like, yeah, like that. Yeah, okay.
It'll do guys.
We're too entertained by stuff like that. We love shapes, you should be proud.
Yeah, save it for later.
Oh, that's me there.
So, what is the length of this arc? Not how many degrees, but what is the length? Because obviously, how many degrees are in that arc? 45. Good, nice job. So the question is, what is the length of that bad boy? I want you to stop right now and think about what we did for the bell work, think about what we did for the last problem, and then talk to your neighbor and see if you can figure out a way to get this on your own. Go.
Would you like find
Oh, yeah.
This is all you this time. Come together.
I don't see this. I mean, there might be another step with
Because what you're gonna do with the radius? I only know one. One's like this and
Yeah, that's exactly what it was.
you never pointed it out to me? Don't you point it out to me? What's the grade in there?
Give me a second, okay?
Sometimes. Wonder her favorite thing. What would you like? What would you
I wake up 5 minutes behind it.
Okay. What's it called?
Fantastic. So it sounds like you guys had some good discussion there.
Yep.
Real quick.
Casey!
Happy birthday, Casey! He said, oh.
How many more? Oh, I did. Thank you. Now that's recorded in history forever. It will live on YouTube. Okay. Thank you. Thank you. So, take a look at your notes because I'm going to pull somebody up and then you're going to share with us what you guys came up with.
Hey, don't talk about that.
I didn't plan that. There's no way I could have done that. Casey, go ahead, bud. What'd you come up with?
Okay, so
How do you do that?
Pi times diameter.
D pi?
Yeah.
So diameter, so if this is 6 for the radius, then the diameter would be 12. So this is 12 pi so far? And 12 pi is the whole circumference? Okay.
And then from there, use the 45-degree angle, and it's like the same process as finding the area.
Absolutely. So if I've got 45 degrees out of 360, then I can just multiply that out. And of course, that's going to give you some percentage, correct? So what is, I mean, is it 8?
Yeah, it's like 8.
Wouldn't it be 1/8?
Yeah, so this would be 1/8. So 1/8 times 12 pi is 12 pi eighths. I can still simplify this further, couldn't I? Just divide this.
Wait, so
I'm so confused.
We have pi.
Thank you. 40, so 360 divided by 45, how many times? So it's 1/8. So remember, this all you're doing is simplifying. So if you take 45 divided by 45, that's 1. 360 divided by 45 is 8. And then we just multiply that out. This can still simplify further to 3 pi halves. And there's the length of that sector.
Can you do another one of those?
For shout.
You mean
Wait. Yes, so.
Arc length?
You said
You said length.
Oh, I'm sorry. Sorry. The arch. It's length of the arch.
Okay.
What class is that in?
It's a little bit more.
You don't need to bring numbers
It's
into
more
this.
work, but
You get the joke though. Why do I
hopefully. I said hopefully.
Yeah. What? Hold on. What'd you say, Helen?
She didn't say anything. Wait, I have to be quiet.
Oh, it'll pick it up. It's right there. Question, and then you can go next. Is it emergency? Go. Breathe. Go. You guys don't look so hot. You guys don't look so hot. Just go. Go straight there. They're both look like. That's not good. It's not good. Okay, so let's take a look at another one. Okay. Find the arc for me, please.
I know, that's what I thought. I was like,
That's 65.
65 degrees. Couple of eyeball.
what? 6 seconds? I did that. Oh, never mind. But don't, I'm sorry.
It's okay.
So,
Oh, that's good. It won't be exact. I think he did just make random numbers.
do it again.
I would.
what did you get?
5.5.
Yeah, but it's not always exact though.
5.54.
Does it have to be stacked?
Why am I getting that? What's the problem with working with fractions?
Alright,
Well,
I
because
get
because no.
I don't
always
like
been
fractions.
terrible at fractions.
So is it over?
I want it exact. You know what? I'm gonna take that back. I want the answer exact. You guys are too afraid of those fractions.
I'm not.
I don't like fractions, but I do.
We like times it, like, how much
No, that's fine. That's not possible.
Why did I put 45?
Is it 77?
That's the answer?
Yeah.
Wait, you can simplify that.
See, I don't like
Never mind.
Coming up, Sam. You guys fighting more than a married couple.
I think they are.
I know, you guys act like it. Oh, okay. Guys, Sam's gonna show us how to do this.
Okay, so 3 equals diameter times pi. That does not look like pi, but oh well. Okay, so then that's 14 pi.
Sam?
It's like we're not like sisters because sisters fight.
What?
Yeah, I'm watching you.
Oh.
I'm gonna do this. And I was trying.
Thank you. So, there was questions for Sam?
She got it.
Okay, anybody else have questions for Sam? Any questions on how to find the length of a sector?
Look at the sector.
Of an arc. Of an arc.
Thank you. Thank you.
Of an arch.
Any questions on how to find the area of a sector? The first part we did. Question on how to find the length of an arc. Okay, pretty simple concepts. Fantastic. Homework is on Canvas. You're a go.
Are we gonna go?